Part C asks us to consider the expression average value between 0 and 0.5, and it gives us our difference quotient. So, what it's asking us to do is find the average value between 0.5 and 1. Well, we're going to need the outputs. Well, I went ahead and calculated the point at 1. It's 64 by plugging 1 into my function. If we plug in 0.5, s of 0.5 is going to give us 60 if you calculate that. So to calculate this expression, well, s of 1 we said was 64 minus s of 0.5, which is 60, over 1 minus 0.5. Or we have 4 over 0.5, or 8. So let's talk about some of the significances of 8. First off, what does it measure geometrically? Well, geometrically, it's the slope between these 2 points. So if I were to connect these 2 points with a straight line, I know the slope between those 2 points, also known as the slope of the secant line between those 2 points. So that's the geometric interpretation of the 8. Now, what does it mean physically? Well, this is the average rate of change between a half a second and 1 second. So, on average, the ball is traveling at an average rate of change of 8. Now that brings us to our last question, is what are going to be the units on this? Well, remember that our function had an output of feet and time was measured in seconds. So this is 8 feet per second. So, what we can say is that between a half a second and 1 second, the ball was traveling on average 8 feet per second. Now, does that mean it was traveling 8 feet per second the whole time? Actually, probably not, because we already know that at 1 second, that's the one point where the ball stops moving because it stops going up and starts going down. So it's actually going 0 feet per second at 1 second. It's probably going a little higher than 8 feet per second at a half a second. But on average, between a half a second and 1 second, we're traveling about 8 feet per second.